The damage to the conduit suggests a high-energy event, possibly a lightning strike. Lightning strikes are capable of generating immense heat and powerful electrical surges. These surges can overwhelm electrical systems and components, leading to catastrophic failures. The melted metal observed in the conduit is indicative of intense heat exposure. The extreme temperatures generated by lightning can easily exceed the melting point of many metals commonly used in electrical conduits such as steel or aluminum. This rapid heating and melting process can cause the metal to deform, bubble, or even vaporize. Furthermore, the shattered plastic components point to the destructive force of the electrical surge. When lightning strikes, the surge of electricity can create a powerful electromagnetic field. This field can induce high voltages in nearby conductors and materials, including plastic conduits. The rapid voltage increase can exceed the dielectric strength of the plastic, causing it to break down and shatter. There are several factors to consider when evaluating the possibility of lightning damage. Firstly, proximity to lightning strikes is a key factor. Areas with frequent lightning activity are more susceptible to lightning damage. Secondly, the presence of grounding systems can influence the severity of lightning damage. Properly installed grounding systems can help to divert lightning energy away from sensitive equipment and reduce the risk of damage. Thirdly, the type of materials used in the conduit can affect its resistance to lightning damage. Metal conduits are generally more resistant to lightning damage than plastic conduits, as they can conduct electricity more effectively. To further investigate the cause of the conduit damage, several steps can be taken. Firstly, a visual inspection of the surrounding area can be conducted to look for signs of lightning damage, such as scorched trees or melted metal. Secondly, electrical testing can be performed to check for insulation breakdown or other electrical abnormalities. Thirdly, a review of weather records can be conducted to determine if there were any lightning strikes in the area around the time the damage occurred. Understanding the potential causes and effects of lightning damage is crucial for ensuring electrical safety. Implementing proper grounding systems, using surge protection devices, and conducting regular inspections can help to mitigate the risk of lightning damage and protect electrical equipment. Always consult with a qualified electrician for any electrical repairs or modifications. The information provided is intended for general knowledge and informational purposes only, and does not constitute professional advice. It is essential to consult with a qualified electrician or electrical engineer for any specific electrical concerns or projects. Firstly, consider the possibility of other sources of damage, such as mechanical stress, chemical corrosion, or vandalism. Mechanical stress can cause the conduit to bend, crack, or break. Chemical corrosion can weaken the conduit material, leading to its eventual failure. Vandalism can result in intentional damage to the conduit. Secondly, analyze the type of plastic material used in the conduit. Different types of plastic have different resistance to heat and electrical stress. Some plastics are more prone to shattering than others. Thirdly, examine the grounding system in the area. A properly grounded system can help to protect electrical equipment from lightning damage, but a faulty or inadequate grounding system can actually increase the risk of damage. Fourthly, review the local building codes and regulations. These codes may specify requirements for lightning protection systems and grounding systems. Fifthly, consider the age of the conduit. Older conduits may be more susceptible to damage due to wear and tear or material degradation. Sixthly, assess the environmental conditions in the area. Exposure to extreme temperatures, humidity, or corrosive substances can accelerate the degradation of the conduit. Seventhly, check for any signs of animal activity. Rodents or other animals can sometimes damage electrical conduits by chewing on them or nesting inside them. Eighthly, determine if there were any recent electrical work performed in the area. Improperly installed or maintained electrical equipment can sometimes cause damage to nearby conduits. Ninthly, evaluate the proximity of the conduit to other electrical equipment. Close proximity to high voltage equipment can increase the risk of electrical damage. Tenthly, review the maintenance records for the electrical system. Regular maintenance can help to identify and address potential problems before they cause significant damage. When investigating the cause of conduit damage, it is important to gather as much information as possible. This information can then be used to determine the most likely cause of the damage and to develop a plan for repair or replacement. The extreme heat generated by a lightning strike can vaporize materials almost instantaneously. The rapid expansion of these vaporized materials can create a shock wave that can shatter even the strongest materials. The combination of heat and pressure can cause the plastic to decompose and break into fragments. It is important to remember that lightning strikes are unpredictable and can occur anywhere. Even if a building has a lightning protection system, there is still a risk of damage to electrical equipment. The best way to protect electrical equipment from lightning damage is to install surge protection devices on all electrical circuits. These devices can help to divert the surge of electricity away from sensitive equipment and reduce the risk of damage. It is also important to regularly inspect electrical equipment for signs of damage. If any damage is found, it should be repaired immediately by a qualified electrician. Remember, safety is always the top priority when dealing with electrical equipment. Always disconnect the power supply before working on any electrical equipment. If you are not comfortable working on electrical equipment, you should always hire a qualified electrician to do the work. The electrical surges can travel through the wiring and damage any connected devices. This is why it is important to use surge protectors on all electrical outlets. Surge protectors can help to protect your electronic devices from damage caused by lightning strikes. The metal may show signs of discoloration or oxidation. The plastic may become brittle or cracked. The conduit may also be bent or deformed. If you notice any of these signs, it is important to have the conduit inspected by a qualified electrician. A lightning strike can also cause a fire. The heat from the lightning can ignite combustible materials nearby. This is why it is important to have a fire extinguisher on hand in case of a fire. It is also important to have a smoke detector installed in your home. Smoke detectors can alert you to a fire early so that you can evacuate the building safely. The electrical surge from a lightning strike can also damage underground utilities. This can include water pipes, gas lines, and telephone lines. If you suspect that a lightning strike has damaged your underground utilities, you should contact your local utility company immediately. They will be able to inspect the utilities and make any necessary repairs. The conduit itself is designed to protect the electrical wires from damage. It is important to use the correct type of conduit for the application. Some types of conduit are designed for use in wet locations, while others are designed for use in dry locations. It is also important to use the correct size of conduit for the wires that it will be protecting. If the conduit is too small, the wires may overheat and cause a fire. The National Electrical Code, or NEC, provides guidelines for the proper installation of electrical conduits. It is important to follow these guidelines to ensure that the electrical system is safe and reliable. The NEC covers various aspects of conduit installation, including the type of conduit to use, the size of the conduit, the spacing of supports, and the grounding requirements. The NEC is updated every 3 years, so it is important to stay up to date on the latest requirements. Article 342 covers intermediate metal conduit, Article 344 covers rigid metal conduit, and Article 352 covers rigid polyvinyl chloride conduit. These articles provide detailed information on the installation and use of these types of conduits. For example, NEC Section 300.11 addresses securing and supporting wiring. Section 314.17 covers number of conductors in outlet, device, and junction boxes, and conduit bodies. Section 310.15 covers ampacity of conductors. Different types of conduit have different properties. For example, rigid metal conduit is very strong and durable, but it is also heavy and expensive. Rigid polyvinyl chloride conduit is lightweight and inexpensive, but it is not as strong as rigid metal conduit. Intermediate metal conduit is a compromise between rigid metal conduit and rigid polyvinyl chloride conduit. It is stronger than rigid polyvinyl chloride conduit, but it is not as heavy or expensive as rigid metal conduit. The choice of conduit depends on the specific application and the environmental conditions. In areas where there is a risk of corrosion, it is important to use a corrosion-resistant conduit. In areas where there is a risk of physical damage, it is important to use a strong and durable conduit. The conduit should be properly grounded to protect against electrical shock. The grounding conductor should be connected to the metal conduit and to the grounding electrode system. The grounding electrode system should consist of a ground rod, a ground plate, or a metal underground water pipe. The grounding electrode system should be installed in accordance with the NEC. The size of the grounding conductor should be determined by the size of the overcurrent protection device protecting the circuit. The grounding conductor should be large enough to safely carry the fault current in the event of a ground fault. The grounding conductor should be installed in a manner that minimizes the risk of damage. The grounding conductor should be protected from physical damage and corrosion. The grounding conductor should be securely connected to the grounding electrode system and to the metal conduit. The connection should be made using approved connectors. The connection should be tight and corrosion resistant. The grounding system should be tested regularly to ensure that it is functioning properly. The grounding system should be tested by a qualified electrician. The testing should be performed in accordance with the NEC. The test results should be documented and kept on file. The conduit should be inspected regularly for signs of damage. The inspection should be performed by a qualified electrician. The inspection should include a visual inspection of the conduit and a test of the grounding system. Any damage should be repaired immediately. The repairs should be performed by a qualified electrician. The repairs should be performed in accordance with the NEC. The repairs should be documented and kept on file. It is important to use the proper tools and equipment when working with electrical conduit. The tools and equipment should be in good working order. The tools and equipment should be used in accordance with the manufacturer's instructions. The tools and equipment should be inspected regularly for signs of damage. Any damage should be repaired immediately. It is important to wear the proper personal protective equipment when working with electrical conduit. The personal protective equipment should include safety glasses, gloves, and a hard hat. Personal protective equipment should be inspected regularly for signs of damage. Any damage should be repaired immediately. It is important to follow all safety precautions when working with electrical conduit. The safety precautions should include disconnecting the power supply before working on any electrical equipment. The safety precautions should also include avoiding contact with energized electrical equipment. The safety precautions should be followed at all times. Electrical work can be dangerous. It is important to be careful and to follow all safety precautions. If you are not comfortable working on electrical equipment, you should hire a qualified electrician to do the work.